They say space is quiet, a vast ocean of silence. But every 22 minutes, like clockwork, a strange signal has been reaching Earth from deep space, and it's been going on for over 35 years. What could possibly be out there trying to reach us with such precision, and how could we have missed it for so long? Imagine the sheer vastness of space, hundreds of billions of galaxies, each with billions of stars, stretching out in every direction, seemingly endless. Yet, in this ocean of stars and planets, a mysterious signal cuts through, like a lighthouse in a storm. Every 22 minutes, this signal, known as GPM J1839-1842, travels across unimaginable distances to reach us here on Earth. It's like some cosmic clock ticking away, and for decades, scientists have been scratching their heads, trying to understand where this message comes from and why. But here's the problem: this signal doesn't match anything we know. It's too rhythmic to be random, too stable to be a natural phenomenon, at least not as we understand it. Pulsars, magnetars, white dwarfs, black holes, scientists have explored all the usual suspects, yet none of them fit. The signal remains unclaimed, almost as if it's taunting us, challenging us to decode it. So what could cause such a strange, precise and persistent signal? And what does it mean for us if we can't figure it out? Let's start from the beginning. How did we even notice this mysterious signal? It all begins with the science of radio astronomy. Back in the 1930s, an American physicist named Carl Jansky was studying radio interference. But in the process, he stumbled on something surprising: radio waves coming from the Milky Way. This accidental discovery marked the birth of radio astronomy, a field that allows us to listen to the universe in frequencies that go beyond what the human eye can see. And as technology advanced, radio telescopes became more powerful, capable of picking up signals from billions of light years away. Today, one of these incredible tools is a network of telescopes called the Murchison Wide Field Array, tucked away in the remote outback of Western Australia. This isn't just a telescope. It's a whole network of thousands of antennas spread out across a desolate landscape, each one acting like a finely tuned ear, straining to catch whispers from the depths of space. The Murchison Array has helped us capture some of the most powerful signals ever recorded, including mysterious fast radio bursts, brief, intense signals that last only milliseconds but release as much energy as our sun produces in nearly a century. And then, among all this cosmic chatter, one signal stood out: GPM J1839-1842. Unlike the fleeting nature of fast radio bursts, this signal was different. It wasn't a quick burst, but a steady, rhythmic pulse. Every 22 minutes, like clockwork, it sent a message across the cosmos. And it wasn't a one-time event either. This signal has been arriving at Earth with unrelenting precision, every 22 minutes, for over 3 decades. So what could possibly cause such an anomaly? Theories began to emerge. Some scientists thought it could be a pulsar, a type of neutron star that spins rapidly, sending out beams of radio waves that we can detect when they sweep across Earth. Pulsars are like cosmic lighthouses, and their signals are incredibly regular. In fact, they're so precise that scientists have used them as cosmic clocks for spacecraft navigation. But there's a catch: pulsars typically emit signals every few milliseconds or seconds. GPM J1839-1842, on the other hand, has a period of 22 minutes. That's way too slow to be any pulsar we know. Oh, what about magnetars? These are also neutron stars, but with magnetic fields so powerful they're almost beyond comprehension, millions of times stronger than any magnet we could make on Earth. Magnetars can produce radio waves, especially during what scientists call starquakes, where the surface of the magnetar shifts, releasing immense energy. But again, this doesn't quite fit. Starquakes are random, violent, and short-lived. They don't produce the steady, almost soothing rhythm that GPM J1839-1842 has. So if not a pulsar or a magnetar, then what? As of now, the mystery of GPM J1839-1842 remains unsolved. Every 22 minutes, it continues to pulse across the universe, defying every model we have, as if it's waiting for us to catch up. We may not know what it is yet, but one thing is certain: it's challenging everything we thought we knew about the cosmos. If you're fascinated by the mysteries of the universe, subscribe and stay tuned for our next deep dive into the unknown.